Hi everyone, it's Miss Berry. In this video we're going to be talking about section 3.1, which is called similar triangles. Similar triangles are triangles that have corresponding sides in proportion to each other and corresponding angles that are equal to each other. So what that means is that similar triangles can look the same, but the length of the sides can be different. There are three different methods that we can use to determine if two triangles are similar or not. So I'm going to tell you about those three methods next. The first method that we can use to determine if two triangles are similar is called the Angle-Angle Postulate, or AA postulate. The Angle-Angle Postulate says, if two angles of one triangle are congruent to two angles of another triangle, then the triangles are similar. Alright, so here on your screen you can see two similar triangles. I'm going to just refresh your memory by showing you how we can name these triangles. So if you remember, the way that we name these triangles, the first one is totally up to you. So you can name the first one however you want. I've named this top triangle as ABC. So let me switch to my laser pointer. A, B, C. All right, so now how I named the first triangle is going to dictate how I name the second triangle. All right, so look at our second triangle. Whenever we named our first triangle, we said ABC, so that's the angle with one tick mark first, then the angle with two tick marks, and then the blank angle. So angle with one tick mark, angle with two tick marks, blank angle. That's how we're going to name the second one. So the name of the second triangle should be triangle DEF. The next method that we can use to determine if two triangles are similar is called the Side-Angle-Side Similarity Theorem. This theorem says if two sides in one triangle are proportional to two sides in another triangle, and the included angle in both are congruent, then the two triangles are similar. All right, so what this is saying is that if you can look at your two triangles and determine that two sides in one triangle are proportional to two sides in another triangle, and the included angle in both is, instead of thinking of this as congruent, you can think of this as just being equal. That might make this a little easier. Right, so the two angles have to be equal, then the two triangles are similar. So here I have two similar triangles that are similar by the Side-Angle-Side Similarity Theorem, and I'm just going to show you how another way that you could name these triangles. So I started by naming this first triangle BCA. So I'm starting with the angle. So I'm starting the name of my triangle with the angle, and then you can see I'm going along the larger side, and then I'm going along the blank side. So starting with the angle, 50 degrees, going along the larger side to C, and then along the blank side to A. So let's do the same thing over here with this triangle. So we're starting with the angle 50 degrees, so that's F. We're going along the larger side, and then going along the blank side, so that's FED. So that triangle would be named FED. So again, how you name the first triangle is totally random. It does not matter how you name the first triangle. What matters is how you name the second triangle. So however you named the first triangle is going to dictate how you name the second triangle. And the last method that we have to prove that two triangles are similar is called the Side-Side-Side Similarity Theorem. And the Side-Side-Side Similarity Theorem says if the lengths of the corresponding sides of two triangles are in proportion, then the triangles are similar. So in this theorem, all of the sides need to be in proportion. All right, so in this example, again, I just wanted to show you one more example of naming these triangles. So I started by naming this one CAB. And again, that is just totally random. I just chose this naming because this is one that I had not used yet today. So I did CAB. C is the angle that is between the largest side and the next largest side. So again, or you could think of it as being the angle that's across from the smallest side. All right, then we go along the largest side and then down the smallest side. All right, so start with the angle that is across from the smallest side, go along the largest side to A, then down the smaller side to B. All right, we're going to do the same thing over here. So let's find the smallest side. That's 20. All right, so the angle across from the smallest side is E, so that's where we're going to start naming this triangle. So E. All right, then we were supposed to go along the larger side, so we're going to go along the larger side to D, and then along the smaller side to F. So this next triangle is going to be named EDF. Right now, when we are writing that two triangles are similar, we have a special symbol for that. This is what it looks like. It's called a tilde, T-I-L-D-E. Right, so this symbol is called tilde. This is on your keyboard if you want to take a second and look at that. It's in the top left corner of your keyboard, right under the escape button, right next to the 1 button. Right, so this is on your keyboard, and let me show you an example of what a similar triangle statement would look like. So this is just, again, a random example. Here I'm saying that triangle ABC is similar to triangle DEF. So triangle ABC is similar to triangle DEF. Right, so whenever you see that tilde symbol, you're going to read it as is similar to. Right, so when you see the tilde symbol, you're going to read that as is similar to. Right, so let's look at some examples. The first example says, determine whether the given triangles are similar. If they are, write a similarity statement and name the postulate or theorem that you used. If the triangles are not, if the triangles are not similar, explain why. All right, so look at these two triangles. If you were to guess what theorem or postulate we should use, would you think this would be the angle-angle postulate or angle-angle similarity postulate, the side-angle-side similarity theorem, or the side-side-side similarity theorem? Definitely the side-side-side, right? Because that's what we're given. We're only given sides of these triangles. We don't know any information about the angles. So if they are similar, it's going to have to be by the side-side-side similarity theorem. All right, so let's recall, what do we need to know in order to prove that two triangles are similar by the side-side-side similarity theorem? Our little checklist for the side-side-side similarity theorem is all we have to check is that are the sides proportional. Right, so we need to name the triangles, and then we need to determine whether the sides are proportional. Right, so let's do that next. Before we can determine if the sides are proportional, we need to name both of the triangles. So let's start by naming the triangle on the left. Again, we're going to name this first triangle randomly. I'm choosing to name this triangle ABC. All right, so let's take a closer look at how we've named this triangle. So I've named this triangle A, B, C. You can see that A is the angle that's in between the largest side and the smallest side. So let's go over here to our other triangle and find the angle that is in between the largest side and the smallest side. Right, here's the largest side, 17. The smallest side is right here, 8. So this triangle is going to start with H. Right, so we know H is going to be the first letter in the name of this second triangle. Right, now let's look back at our triangle on the left. Right, so this triangle was named A, B, C. So I need to start with my first angle. I'm going to go along the largest side. All right, so start with my first angle H, go along the largest side, which is 17, so that's going to be H, K, and then my last side is going to be G. Okay, that's the only direction I can go. I can't go back to H. So if I went from H to K, the only place that I have left to go is G. Right, so my second triangle is going to be named HKG. Right, now that I have named both triangles, I can now start checking if their sides are in proportion. Right, so I'm going to start by looking at my largest side on my triangle on the left and my largest side on the triangle on the right, and I'm going to create a ratio. Right, so my first ratio is going to be 68. I'm always going to put the triangle on the left in the numerator and the triangle on the right in the denominator. That's just the way that I do it to keep that pattern the same in my head. Right, so my triangle on the left gives me the largest side of 68. The triangle on the right has the largest side of 17. So I'm going to start with my fraction being 68 over 17. And then I'm just going to go along this next side here, BC. You could do AC, it doesn't matter. Again, you have to check that all the sides are proportional, so it does not matter where you start. You have to check every one. Right, so I'm doing 68 over 17. And then I'm also going to look at the next largest side, which in the triangle on the left is 60. The next largest side in the triangle on the right is 15. All right, so let's set up our proportion. All right, so we have 68 over 17. And we want to check that that is in proportion to our second ratio, 60 over 15. So you can see I put the equal sign with the little question mark here because I don't know that they're equal. I'm checking right now to see if these are in proportion. The way that I'm going to do that is to cross multiply. You can also just simplify both fractions. That would work as well. So I'm just cross multiplying to check if these two fractions are in fact proportional. So I'm going to multiply that way, right? So 15 times 68 is 1020. So we're going to check and see, is that equal to 17 times 60? 17 times 60 is 1020, so those two sides are in proportion. So that checks out. All right, so now I just need to make sure that my last side is in proportion to those two sides. So I'm going to start by, I'm going to go over here. And I'm going to say, okay, I'm just going to pick one of these fractions. Let's do 60 over 15 because that one seems a little bit easier to work with. 60 over 15. I'm going to set that equal to, now I'm looking at my smallest sides. All right, so my smallest sides, let's use a different color. I can't tell a difference there. Yeah, that's better. Dang. All right, so let's not use the highlighter. Let's do this. All right, so now I'm looking at this smallest side and this smallest side. And again, my triangle on the left is always going in the numerator. My triangle on the right is always going in the denominator. So that's 32 over 8. All right, now I'm going to cross multiply to check that. And so let's cross multiply. All right, 60 times 8 is 480. And again, I'm putting a little question mark here because I don't know that these are in proportion. I'm checking that right now. So 480. And let's check and make sure what's 15 times 32. 15 times 32 is also 480. So that checks out. That last smallest side is also in proportion. So going back to our checklist, all we needed to check is that the sides were proportional, and they were. So these two triangles are similar. Now I just need to write my similarity statement. So my similarity statement here is going to be triangle ABC is similar to triangle HKG. So triangle ABC is similar to triangle HKG by the side-side-side similarity theorem. Right, let's look at another example. Same directions. It says determine whether the given triangles are similar. If they are, write a similarity statement and name the postulate or theorem that you used. If the triangles are not similar, we need to explain why. All right, so let's take a look at these triangles. Do you think that we should use the angle-angle postulate, angle-angle similarity postulate, the side-angle-side similarity theorem, or the side-side-side similarity theorem? What do you think we should use? Definitely the side-angle-side similarity theorem, right? So we've got side, angle, side, side, angle, side. All right, so we're going to use the side-angle-side similarity theorem to check and see if these two triangles are similar. And here's my little checklist. For the side-angle-side similarity theorem, we need to check, are the angles congruent? And remember, that's just a fancy word in this case that means equal. So congruent here just means equal. And I also need to check that the sides are proportional. All right, so let's get started. Are the angles equal? Yes, they are. They're both 80 degrees. All right, so check. We're already halfway there. Now we just need to check that the sides are proportional. All right, so I'm going to start by naming this triangle on the left UGA. All right, so again, how you name the first triangle is totally random. I named this one UGA, just kind of started on the left and went around clockwise. Right now I need to do the same thing for this triangle on the right. All right, so the angle U is the angle U is across from the smallest side. All right, so the angle that is across from the smallest side, that's 18, is F. All right, so we're going to start with F. All right, then we go along the larger side, and then we go down the smaller side. All right, so we're going to go along the larger side. So start with F, go along the larger side, and then down the smaller side. So this triangle is going to be named FEB. FEB. All right, so let's set up our proportions and check and see if these two triangles, check and see if these sides are proportional. All right, so we're going to start. I'm going to start with this larger side on the left. And remember, I'm always putting my triangle on the left in the numerator, my triangle on the right in the denominator. All right, so the first little fraction that we're going to set up is going to be 20 over 24. So largest side over largest side. And then we're going to check and see, is that equal to the smallest side over the smallest side? So smallest side on the left is 15, smallest side on the right is 18. So 15 over 18. And again, to check if these are proportional, you can just simplify the fractions, that's fine. I'm choosing to cross multiply here, and that's what I'm going to do next. I'm going to cross multiply 18 times 20, then I'm going to do 24 times 15 and check and make sure those are equal. 18 times 20 is 360, and we're going to check and see, is that equal to 24 times 15? 24 times 15, what is that equal to? 24 times 15 is also 360, so our sides are in proportion. So that checks out. So let's go back to our checklist. We already checked and made sure the angles were equal or congruent. And then we were checking to see, are the sides proportional? They are, so we can check that off. So we have checked both of our criteria off the side-angle-side similarity theorem checklist. And so we just now need to write our similarity statement. All right, so here we're going to say triangle UGA is similar to triangle FEB by the side-angle-side similarity theorem. So again, same directions. This time it says determine whether the given triangles are similar. If they are, write a similarity statement and name the postulate or theorem that we're using. And if they're not similar, explain why. So I want you to try this one. If you need a hint, you can stick around for just a minute. If you feel confident, go ahead and get started. So pause the video and get started. All right, if you stuck around because you needed a little hint, then I want to nudge you in the right direction by encouraging you to look at both of these triangles and think to yourself, would I use the angle-angle postulate, the side-angle-side theorem, or the side-side-side theorem? Which similarity theorem or postulate do you think we should use here? Definitely side-side-side, right? So the side-side-side similarity theorem checklist is, are the sides proportional? All right, so the next thing you need to do is name the triangles. All right, so I want you to give this a shot. So pause the video if you haven't already and start naming the triangles. I'm going to name the triangle on the left JKL. All right, so I'm naming the triangle on the left JKL. If you ended up naming it something different, that is totally fine. Your triangle on the right is going to be named something different than mine because it's totally dependent on what you named this first triangle. All right, so if you named it LKJ, then your name for the triangle on the right is going to be different than mine, and that's okay. Right, so if you name this first triangle JKL, then the triangle on the right is going to be named QRP. Right, QRP. All right, now I'm checking to see if the sides are proportional. To do that, I'm doing smallest side over smallest side, and then middle side over middle side. All right, so I'm going to set up that proportion. 64 over 44 equals 75 over 60. So again, triangle on the left always goes in the numerator, triangle on the right always goes in the denominator. All right, so now I'm going to cross multiply to check if these are in fact in proportion. 60 times 64 is 3840. 3840. All right, so 60 times 64 is 3840. What about 44 times 75? 44 times 75 is 3300. All right, so those are not equal. So those sides are not in proportion. So going back to our checklist, the sides are not proportional. So the triangles are not similar, and we're supposed to explain why. So I said the triangles are not similar because the sides are not proportional. So very simple explanation. Right, and here we've got an example of an application problem. So just a little word problem with similar triangles. It says a triangle is formed by a building's height and shadow. Another triangle is formed by a flagpole's height and shadow. Using the diagram below, find the height of the building. All right, so we're going to set up a proportion here to figure out the height of the building using these similar triangles. All right, so I'm going to start with the shadow. So I'm going to do triangle on the left over triangle on the right. So my triangle on the left has a shadow of 20 feet. My triangle on the right has a shadow of 4 feet. So that's 20 over 4. We're going to set that equal to the ratio of the heights. So the height of the building is x, the height of the flagpole is 20. So again, triangle on the left goes in the numerator, triangle on the left goes in the numerator, triangle on the right is going to go in the denominator. So that's going to be x over 20. Now I just need to cross multiply to solve for x. All right, so 20 times 20 is 400. 4 times x is 4x. So that's going to be 400 equals 4x. Divide both sides by 4. All right, so divide both sides by 4 and you get x equals 100. All right, so again, x was the height of the building. So to put this in context, we would say the building is 100 feet tall. That's everything that I have for similar triangles. If you have any questions, please let me know, and I'll see you guys in the next video. Have a good day.